Hi, welcome back to my class in trigonometry. And for today, we will take up standard angle in standard position, which we will draw in the Cartesian plane. We will differentiate positive angle from negative angle. And we will take up the three distances associated with any point on the terminus side of an angle in standard position. For those of you who missed the lessons before in plane trigonometry, search for my videos. Art teaches trigonometry. In geometry, we know that an angle has three parts. An angle, say angle A, has an initial side and a terminal side, and these sides are raised and they both originate from the same point, say point A, and point A is the vertex of the angle. In geometry, an angle is measured in degrees, but you will learn in trigonometry that there are other units for angular measurements. The angle A is the number of degrees in the opening between the initial ray and the terminal ray. And the angle A is the number of degrees that the terminal side of the angle makes with the initial side of the angle. The terminal side of the angle is usually fixed, and the terminal side is rotating from the initial side about the fixed point A, which is called the vertex of the angle. Now we will construct an angle in standard position in the Cartesian plane. This is the Cartesian plane. It consists of two axes, the horizontal axis denoted by x, and the vertical axis denoted by y. And the two axes divides the plane into four quadrants, counted from this first quadrant in counterclockwise direction. The intersection of the axes is denoted by point 0, known as the origin. At the origin or point 0, the coordinates of the point are 0, 0. In the Cartesian plane, an angle in standard position has the vertex at the origin. Again, the vertex of an angle in standard position in the Cartesian plane has vertex at the origin. The initial side of the angle in standard position is fixed at the positive side of the x-axis. This is the initial side of the angle in standard position in the Cartesian plane. And the terminal side will rotate about the origin, the vertex of the angle, from the initial side. The terminal side can go in counterclockwise direction or in clockwise direction. If the terminal side of the angle goes from the initial side in counterclockwise direction, suppose this is the terminal side of the angle, and it originates from the initial side and it moves in counterclockwise direction to this position. The number of degrees in the opening between the initial side and the terminal side with vertex at the origin is an angle that is positive. An angle in standard position has vertex at the origin and the terminal side is fixed at the positive side of the x-axis. The terminal side can go from the initial side in counterclockwise direction or in counterclockwise direction. If the terminal side moves in counterclockwise direction, the angle is said to be positive. So a positive angle in standard position is measured from the initial side on the positive x-axis in counterclockwise direction. If the terminal side moves beginning from the initial side on the positive x-axis and it moves in clockwise direction, say the initial side, the terminal side moves from the initial side up to this. This is the terminal side of the angle with vertex at the origin and initial side on the positive x-axis. The angle that is measured from the initial side in clockwise direction is a negative angle. So a negative angle is an angle in standard position with vertex at the origin, initial side on the positive x-axis, and is measured from the initial side in clockwise direction. A positive angle is an angle in standard position with vertex at the origin and is measured from the initial side on the positive x-axis in counterclockwise direction. An angle in standard position is an angle with vertex at the origin and initial side on the positive x-axis, and the terminal side can be in any quadrants of the Cartesian plane. If the angle is measured from the initial side to the terminal side in counterclockwise direction, the angle is said to be a positive angle in standard position. If the angle theta, say theta, is measured from the initial side to the terminal side in clockwise direction, the angle is said to be a negative angle. We now take a positive angle in standard position in the Cartesian plane. So angle theta here measured from the initial side on the positive x-axis is positive. As you can see, the direction of arrow that gives the direction of the angle theta begins from the initial side on the positive x-axis and it goes in counterclockwise direction to the terminal side of the angle theta. And the angle theta is in standard position because its vertex is at the origin and its initial side is on the positive x-axis. The terminal side of the angle theta is in the first quadrant. Hence, we can also say that the angle theta is an angle in quadrant 1. So, an angle in standard position is identified by the position of its terminal side. If you say the angle theta is in the third quadrant, then its terminal side lies in the third quadrant. If you say that the angle theta is in the second quadrant, or if you say the angle theta is an angle in the second quadrant, then its terminal side lies in the second quadrant. Now we will take any point P on the terminal side of the angle theta. Say this is point P. You can take any arbitrary point on the terminal side of the angle theta. We will now identify the three distances associated with any point P on the terminal side of this positive angle theta in standard position. If you project the point P down to the x-axis and perpendicular to the x-axis and parallel with the y-axis, from point P, project a straight line perpendicular to the x-axis. So this line segment from P to this point makes a right angle with the initial side of the positive angle theta in standard position. And this line is parallel with the y-axis. The distance of point P from The perpendicular distance of P from the positive x-axis or the initial side of the angle theta is the distance of P from the x-axis, and it is given by the ordinate of P or the second coordinate of P. And the distance of point P, if you project P perpendicular to the y-axis, this distance is equal to this distance. So the distance of point P from the y-axis is the abscissa of point P. The abscissa x of point P gives the distance of P from perpendicular distance of P from the y-axis. And the second coordinate of P, the ordinate y of P, gives the perpendicular distance of point P from the x-axis. So we write the coordinates of point P. Coordinates of point P are x and y. These are the first two of the three distances associated with point P on the terminus side of the angle theta in standard position. The first distance is given by the abscissa, the first coordinate of P abscissa, which gives the distance of point P from the y-axis. And the second coordinate of point P, y, the ordinate of P, gives the perpendicular distance of P from the x-axis. The third distance associated with any point P on the terminus side of the angle theta in standard position is the distance of the point P from the origin or from the point 0. And this distance is usually denoted by small r. And small r is known as the radius vector. R is the radius vector, and it gives the distance of point P from the origin. You can see that in this diagram we have constructed a right triangle with the right angle at this point of intersection of the initial side of the angle theta and the perpendicular distance of P to the x-axis. And the side opposite this right angle is r, the radius vector of P or the distance of P from the origin. And the two other legs of this right triangle have lengths given by the abscissa x and the ordinate y of point P. And using these three sides of this right triangle, we now write the Pythagorean theorem, which we have stated last time, and it states that the square of the hypotenuse is the side opposite the right angle, and by Pythagorean theorem, the square of the hypotenuse is equal to the sum of the squares of the two other sides of the right triangle, known as the legs of the right triangle. So we write the relationship among these three distances associated with point P on the terminal side of the angle theta in standard position using Pythagorean theorem. By Pythagorean theorem, we write the square of the hypotenuse. The hypotenuse is r, or the length of the hypotenuse is r. And the square of the hypotenuse is given by r squared. By Pythagorean theorem, this is equal to the sum of the squares of the two other sides, or the sum of the squares of the legs of this right triangle. And the square of the first side is given by x squared. And the square of the third side is given by y squared. This is the equation that relates the radius vector of a point P on the terminal side of the angle theta in standard position to the abscissa and ordinates. of point P. We will now take an example for applying this relationship. We now consider an example. Consider the following. Find the abscissa of P. P is a point on the terminal side of theta. Theta is an angle in standard position. And theta, it says here that the angle theta is greater than 0, which means that the angle theta is a positive angle in standard position in Q2. So the angle theta is a positive angle standard position in Q2, that is in the second quadrant, which means that the terminal side of the angle theta lies in the second quadrant, whose radius vector, the radius vector of P, and we know that radius vector is the distance of point P from the origin. And the radius vector of point P is given, it is 5 or 5 units. And its distance from x-axis is 3 units. It means that the distance of point P from the x-axis is 3 units. Again, the required is to find the abscissa of point P, the first coordinate of P. And the point P is a point on the terminal side of the angle theta. P is on the terminal side of the angle theta. The angle theta is an angle in standard position, which means that the vertex of theta is at the origin, and its initial side is on the positive side of the x-axis. It is given that the angle theta is greater than 0, which means that the angle theta in standard position is a positive angle, which means that we will measure theta, the angle theta, from its initial side on the positive side of the x-axis in counterclockwise direction going to its terminal side. And the terminal side of the angle theta lies in the second quadrant, because it is said that it is given that the angle theta is in Q2 or second quadrant. We are also given the radius vector of P, 5 units, which means that the distance of point P from the origin is 5 units. And the last given is the distance of point P from the x-axis, which is 3 units. And we know that the distance of a point P on the terminal side of an angle is given by the second coordinate of point P, y. So the ordinate y of point P on the terminal side of the angle theta is 3 units. The radius vector of point P, the distance of P from the origin, denoted by small r, is 5 units. And we want to find the abscissa of P. The abscissa of point P is the first coordinate of P, denoted by x. We now write all the information given from this problem. We write given the angle theta is positive, greater than 0, and its terminal side lies in the second quadrant, Q2. The radius vector of point P is given. The distance of point P from the origin is 5 units. We write r equals 5. The distance of P from the x-axis is given, and the distance of a point from the x-axis is given by y. So the ordinate of point P is 3 units. And the required, we are asked to find the abscissa abscissa of point P, or the first coordinate of point P. Now we construct the angle theta in the second quadrant. It is important that you draw the angle in a diagram because the values of x and y can be positive or negative. These coordinates of a point are actually represent directed distances, which means that their values can be negative or positive depending on which quadrant the point lies. We construct the Cartesian plane. The initial side of the angle theta lies in the positive side of the x-axis. This is the initial side of the angle theta. And the angle theta in standard position has vertex at the origin. The vertical axis is denoted by y. Because the angle theta is in the second quadrant, we know that its terminal side must lie in the second quadrant. So we approximate the angle theta. We are sure that its terminal side lies in the second quadrant because the problem says theta is in Q2, or the second quadrant. And the angle theta is positive, which means that the angle theta is measured from the initial side, from its initial side on the positive side of the x-axis in counterclockwise direction up to its terminal side in the second quadrant. So we indicate the angle theta measured from the initial side in counterclockwise direction to the terminal side of the angle theta. And this is the angle theta. And the angle theta is positive. Now we take the point P on the terminal side of theta. Suppose this is point P. This point has an abscissa and ordinate y. The required here is to find the value of x, or the abscissa of point P. But the ordinate of point P is given y equals 3. And y equals 3 is the distance, the point P, the perpendicular distance of point P from the x-axis or horizontal axis. So from this point P, we project a perpendicular line, a line perpendicular to the x-axis. And the distance of point P from the x-axis is 3 units. We are also given that r is 5 units, and r is the distance of point P from the origin. We write r equals 5 units. The distance of point P from the origin is 5 units, and this 5 units is actually the length of the hypotenuse of this right triangle we have constructed. R is the length of the side of this right triangle opposite the right angle. The distance of point P from the y-axis, this length, which is equal to this side of the right triangle, is the value of x that we want to find. We want to find the value of x, the first coordinate of point P, which gives the distance of P, actually the directed distance of P from the y-axis. When we solve for value of x, we expect the value of x to be negative, because the point P is in the second quadrant, where the value of the abscissas of the points in the second quadrant are negative, or the point P is to the left of the y-axis, and all the points to the left of the y-axis have negative abscissas. Now we write the relationship among the radius vector and these two other sides of this right triangle by Pythagorean theorem. And the Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the squares of the two other sides of a right triangle. So we write the equation using Pythagorean theorem that relates r, and this is y is given, the ordinate of point P is given, y is 3. We write the equation that relates the radius vector and the abscissa and the ordinate of point P using Pythagorean theorem. The square of the hypotenuse, r square, is equal to the sum of the squares of the abscissa and the ordinate of point P. Square of abscissa is given by x squared. The square of the ordinate is given by y squared. And from this equation, we substitute the given r and the given y. R is 5 units. 5 squared equals x squared plus y is 3 squared. From this equation, we can solve for x by simplifying. Square of 5 is 25 equals square of x plus the square of 3. The square of 3 means 3 square means you multiply 3 by itself twice. So 3 square is 3 by 3. 3 square is not equal to 3 multiplied by 2. It means you multiply 3 square means you multiply 3 by itself 3 times. Hence 3 square is 3 multiplied by 3 and is equal to 9. When you are solving for a value of a variable, all the constant terms must be at one side of the equation. So we transpose positive 9 to the left side of the equation. And on this side, we will have x squared. X squared equals 25. And transpose positive 9 to the other side, we take the opposite side. We get minus 9. And x squared equals 25 minus 9 is 16. And finally, we extract the root of both sides. Square root of x squared and the square root of 16. The square root of x squared is x. And the square root of 16 are positive, plus and minus 4. Any positive real number has two roots, the positive root and the negative root. The positive root is referred to as the principal root, and in many problems in mathematics, we are interested only with positive root or the principal root because the negative roots have no significance in real life problems. But in this case, we take both the positive and the negative roots because the abscissa of a point in the Cartesian plane can be negative or positive depending on the location of the point P in a quadrant of the Cartesian plane. In this particular example, we are looking for the value of x, and the value of x should be negative because the point P is to the left of the y-axis, where the abscissas of the point P in this second quadrant or third quadrant are negative. So for this abscissa of point P, we take the negative root of 16. Hence, the abscissa of point P that we are looking is negative 4. The distance of point P from the y-axis is 4 units. And the negative sign here indicates the position of point P. That means point P is to the left of the y-axis, or the value of the sign negative here indicates that the abscissa axis is at the left side of the x-axis or the horizontal axis. And you can check this by substituting -4 to the Pythagorean theorem. To this equation, 5 squared, replace r with 5 units, replace x with -4, and the square of -4 is positive 16, and add the square of y, which is 3 squared, and you have 16 plus 9 equals the square of r, or the square of 5, which is 25. Take another example. In this example, the angle theta in standard position is negative. Find the ordinate of P, and the ordinate of P is given by y. Y is the second coordinate of point P in the Cartesian plane. And the point P is on the terminal side of theta. The angle theta is in standard position, which means that the vertex of the angle theta is at the origin and its initial side is on the positive x-axis. And we are given that the angle theta is less than 0, which means that the angle theta in standard position is negative, which means that the angle theta is measured from its initial side on the positive x-axis, on the positive side of the x-axis, in clockwise direction towards its terminal side. And the angle theta is an angle in Q3, which means that the angle theta is an angle in the third quadrant, which means that when you draw the angle theta in the Cartesian plane, its terminal side must lie in the third quadrant. And you must measure the angle theta in clockwise direction from the initial side on the positive side of the x-axis to its terminal side in the third quadrant. The radius vector of point P, that is the distance of point P from the origin, is 5 units. And it is also given that the distance of point P from the y-axis is 4 units. And we know that the distance of point P from the y-axis is given by the first coordinate of point P, or is given by the abscissa x of point P. We write the given information to facilitate us in constructing the angle theta in the Cartesian plane. The angle theta is negative, less than 0, which means that we will measure the angle theta from its initial side on the positive side of the x-axis in clockwise direction towards its terminal side. And the angle theta is in the third quadrant, theta less than 0 in Q3, which means that the terminal side of the angle theta lies in the third quadrant. We are also given the radius vector of point P is 5 units. That is, the distance of point P from the origin is 5 units. And the distance of point P from the origin is denoted by small r. We write r equals 5 units. And the last information given is the distance of point P from the y-axis. And its distance from the y-axis is 4 units. We know that the distance of a point P from the y-axis is given by x. X is the abscissa, or the first coordinate of point P. X equals 4. In this given x equals 4, this is undirected distance. This does not specify the direction of x, the actual value of x, the directed distance of the directed distance of point P from the y-axis will be indicated by positive or negative sign. And we will know later on whether the directed distance of point P from the y-axis is negative or positive when we actually construct the angle theta in the third quadrant. So we do that now. We construct the angle theta in the Cartesian plane because the angle theta is in standard position. Its initial side is on the positive side of the x-axis. The horizontal axis is denoted by x, and the initial side of the angle theta is on the initial side of the angle theta in standard position is on the positive side of the x-axis. The vertical axis is denoted by y. The intersection of the two axes is denoted by the origin, which is the vertex of the angle in standard position. And because the angle theta is in the third quadrant, its terminal side must lie in the third quadrant. We approximate the terminal side of the angle theta. Angle theta is in the third quadrant. This is the first quadrant, second quadrant, and third quadrant. And we find the terminus side of the angle theta in the third quadrant because the problem says theta is in Q3 or third quadrant. Now we indicate the angle theta because it is negative. The angle theta is measured from its initial side on the positive side of the x-axis in clockwise direction. We measure the angle theta from this initial side, the positive x-axis, going to the terminus side in clockwise direction. And we indicate that by this arrow, and theta is negative. Next, you take any point P on the terminus side of the angle theta. The angle theta here again is in standard position. Its vertex is at the origin. Its initial side is on the positive side of the x-axis. The angle theta is in the third quadrant because its terminus side is in the third quadrant. And the angle theta is negative because we measured theta from the initial side on the positive side of the x-axis in clockwise direction to its terminus side in the third quadrant. The distance of point P from its vertex, the origin, is given. And the distance of P or from the origin or its radius vector is 5 units. So we write R equals 5 units, or R is 5. The distance of point P from the y-axis is given, and it is 4 units from the y-axis. In this diagram, we first construct the right triangle. And when you construct a right triangle, you always project the point P to the horizontal axis, never to the vertical axis. To construct the right triangle, always draw a line perpendicular to the x-axis from the point P on the terminus side of the angle. Hence, from point P, we draw a line perpendicular to the x-axis because this line from point P is perpendicular to the x-axis. This line and the x-axis form a right angle indicated by this small square. The distance of point P from the y-axis is 4 units. And this distance is the same as this side, the length of this side of the right triangle. And we write x equals, x is 4 units. That is the distance of point P from the y-axis, or which is equal to this length, this side of the right triangle is 4 units. Now we will specify the sign of the value x based from this diagram because point P is to the left of the y-axis, or point P, and because P is a point to the left of the y-axis, all the points to the left of the y-axis, the values of their abscissas or x are negative. Or because point P is in the third quadrant, any point in the third quadrant has a negative value for x, or the abscissa of any point in the third quadrant is negative. So we write x, the abscissa of P is negative. We specify that the point P by writing negative 4 is to the left of the y-axis, which means that its abscissa is negative. And the required is to find the ordinate of P. We write required. The required is y. Y is the ordinate of point P, or we write y is unknown. Y is the distance of point P from the horizontal axis or x-axis. And from when you solve for the value of y, you must also indicate the sign of y, whether it is positive or negative. And from this diagram, you know that the value of y must be negative because the point P is below the x-axis, and all the points below the x-axis, the value of the coordinate, the value of the ordinate, or the value of the second coordinate of points below the x-axis given by y are negative. So when you solve for y, you take the value of y should be negative. Thus, it is very important to construct the angle in the Cartesian plane for you to know the sign of the values of x and y. And we will now solve for y by Pythagorean theorem. And the Pythagorean theorem again states that the square of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the two other sides, or the legs of the right triangle. We write the square of the hypotenuse denoted by r. The square of r, or the square of the hypotenuse, is equal to the sum of the squares of the two other sides. The two other sides are denoted, the two other sides of the right triangle are denoted by x and y. And their squares are written as x to the power 2 and y to the power 2. Now we substitute the given values and solve for the unknown value. R is given, R is 5. We write 5 squared equals x. Our x is negative 4. So we write negative 4 in a parenthesis. To the power 2 plus y squared. From this equation, we can now solve for y. The square of 5 is 25. And the square of negative is positive. The square of 4 is 16. Plus y squared. Again, when solving for the value of a variable, all the constant terms will be at one side of the equation. So we transpose positive 16 to the other side, and we are left with y squared on this side of the equation, or y squared equals 25. And transpose positive 16 to the other side, you get minus 16. Because whenever you transpose a term, you take its opposite side. Hence, y squared equals 25 minus 16 is 9. And to solve for the value of y, we extract the root of both sides. We get the square root of y squared is y. And 9 is a positive real number. A positive real number has always two roots. The positive root and the negative root. And the root of 9 is 3. Now we decide which of these two values of y we will take. Going back to this diagram, the point P is in the third quadrant. And any point in the third quadrant, the value of its ordinate or second coordinate y should be negative. Or the point P is below the x-axis, and all the points below the x-axis, the values of their ordinates are negative. Therefore, the final answer for y is negative 3. Which means that the point P is 3 units from the x-axis. And the negative sign indicates that point P is below the x-axis. For your practice, please try the following exercises. In these problems, the angle theta is in standard position. You construct the angle theta in Cartesian plane in standard position, which means that the vertex of the angle theta is at the origin, and the initial side of the angle theta is on the positive side of the x-axis. Number 1, find the abscissa. point P on the terminus side of theta greater than 0. Theta is greater than 0. That means the angle theta is positive. When you construct theta in the Cartesian plane, you measure it from its initial side on the positive side of the x-axis in counterclockwise direction to its terminus side. And the required here is the abscissa, which means you are to find the value of x, the first coordinate of point P. The angle theta is in the first quadrant, Q1, first quadrant. So when you construct the angle theta in the Cartesian plane in standard position, its terminus side must lie in the first quadrant. The radius vector of point P is 7, which means that the distance of the point P on the terminus side of theta is 7 units from the origin. You should note that r is always positive. The radius vector is always positive. And it's only the values of x, the abscissa, and y, the ordinate of point P, that can be positive or negative, but the radius vector r is always positive. The distance from x-axis of point P is 4 units. The distance of P from the x-axis is 4 units. And that is the ordinate of point P denoted by y. Number 2, find the ordinate of P. That means in this problem you have to find the second coordinate of point P denoted by y. Y is the ordinate of point P. P is on the terminus side of the angle theta. Angle theta is in standard position. And here in number 2, the angle theta is negative, which means that when you draw the angle theta in the Cartesian plane in standard position, you measure the angle theta from the initial side on the positive side of the x-axis in clockwise direction to its terminus side. And its terminus side is in quadrant 4, because it says here theta is in Q4, quadrant 4. When you draw the angle theta, its terminus side must lie in the 4th quadrant. The radius vector of P on the terminus side of theta is given. It is 6 units from the origin. The point P on the terminus side of the angle is 6 units from the origin. And the distance of P from the y-axis is 3 units, which means that the value of the first coordinate of point P denoted by x is 3. The distance P from the y-axis that is given by the value of x is 3 units. The distance of P from the y-axis is 3 units, which means that the first coordinate of P denoted by x is 3 units. If you have questions about the lesson today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalison. And thank you for joining me in this class today, and I'll see you in the next lesson.